Today, I'm going to introduce about flywheel energy storage. Let's see how it works. The flywheel is surrounded by vacuum enclosure, and when you look at the inside, it is composed by magnetic bearing, cylindrical rotor, shaft, and a motor generator. By accelerating a rotor as a flywheel to a very high speed and maintaining energy in the system as a rotational energy, it is reliable, cost-effective, and environmentally friendly. Here's this example NASA Glenn G2 flywheel. There is more benefits about this energy storage, but I will tell you more advantage later. Now, I will tell you about the first commercial applications. Flywheel was the first to be used in commercial applications back in the 1950s in buses that used heavy steel flywheels as their solar energy storage mechanism. This vehicle got the name of gyrobus. Gyrobuses could travel about 5 km on a full charge between recharging stations. Recharging would take no more than 3 minutes, since flywheels can easily absorb high voltage electrical currents. These buses were also equipped with regenerative braking system that recharged the flywheel. Commercial gyrobus service was started in Switzerland, connecting Yves-Dans-les-Bains and Grandson in 1953, and soon after service were initiated in several routes in the city of Kinshasa in the Belgian Congo. With time several problems came up, mostly due to a huge weight of this machine. The gyrobuses used in Congo weighed more than 10 tons. They were hard to drive, damaged roads, and overall were electrically guzzler. A tram used on the same service could easily slash electricity consumption by the third. By the end of 1960, all of the gyrobus routes mentioned above have been scrapped. So how it changes? The first generation used mechanical bearing to reduce friction. Then, next generation used magnetic bearings to reduce more friction. The future technology is using superconducting bearing. There is this old flywheel in 1959. In this picture, flywheel has a fixed diameter and mass, and therefore the fixed moment of inertia. This ingenious 1959 flywheel system designed by Bertram Smish can fold in and out to increase or decrease the energy it stores. How does it work? The driving motor, the green light one, powered the load, orange left one, through on axle, the yellow column one, and pulley system, the colored gray. As the speed of the axle changes, a centrifugal governor, as dark blue one, and electric circuit, top right one, switch a small electric motor, as a pink color, on or off. Moving a linkage, the color as brown, to the left or right. Moving another linkage to the blue color, so the flywheel, the red color, fold in or out as necessary. This is patterned by Graham Smith, published December 1st, 1959. Here's the example of NASA Glenn G2 flywheel. NASA Glenn Research Center has 3 decades of experience in flywheel energy storage systems and is currently making investments to transition this experience from the realm of space application to the broader markets of terrestrial use. Let's compare to electric batteries. The impact of the temperature is smaller, so flywheel can operate at more conditions and environments. Also can measure the amount of energy stored just by the measurement of the rotational speed, and also had longer life. There's this comparison picture of the electrochemical and the mechanical storage like a flywheel. The electrochemical has a short span life, but a mechanical flywheel has a longer lifespan. Let's talk about development compared to mechanical bearings. Mechanical bearings use 5,000 RPM, but magnetic bearing can be 60,000 RPM, so the turning speed becomes higher. It can also last decades with little or no maintenance, so that longer life. And also 90% of high energy efficiency and 360 to 500 kilojoule per kilogram, that high specific energy, and also large power output. Unfortunately, there is disadvantage for some features: power, material, cost, weight, failure, bearings, angular momentum. Lots of power needs to ensure vacuum environments. In power transfer, copper post, stud, or heavy gauge wire feed rods are needed. The materials used are expensive. Alloy flywheel can easily weigh several tons. For transfer application, this can be a serious issue, due to the added inertia that imposed on acceleration and braking. If a flywheel fails by some reason, that high rotation, it disintegrates, sending shrapnel as fast as bullet in random direction. To prevent damage, they be must kept within an armored container, adding future weight to the system. Alloy bearings prove to wear out quite rapidly, at first reducing efficiency and later rendering the flywheel useless, later changing to magnetic bearing. The momentum stored in the flywheel act against direction changes, which in transport can make turns a complex task. Here is the reference list which I used in the video. Thank you very much for providing this information to make this video, and thank you for listening.